To find or work out a triangle side length via a trig ratio, we need to know the angle and one other length. To find an angle, we need to know two side lengths. And the trig function we use, either sine, tan or cos, is completely dependent on which sides we either know or which sides we want to find out. And this will all make a bit more sense when we do some examples. And I call the sides that we want to know, or that we already know the lengths of, I call them the sides of interest, because the other ones aren't relevant to us. Trig functions are to find lengths, or more specifically the ratio of lengths, or how one length of a triangle side changes compared to another length. When the side lengths in question or of interest to us are the opposite side and the hypotenuse, we use the sine function. So the sine of this angle from SOH, the sine of this angle is equal to the length of this side, the blue one, divided by the length of the hypotenuse. And to put it in equation form, the sine of theta, where theta is the angle, or you could call it anything really, as long as you know that the sine function is always of an angle, that number that you get from putting sine of an angle into your calculator is equal to the length of the opposite side divided by the hypotenuse length. And usually you'll be given the angle and one of these two sides, so you can work out the other side. When the sides of interest are the adjacent and the hypotenuse, we use the cos function, because the cos of this angle, or the cosine of this angle, is equal to the ratio between the adjacent length divided by the hypotenuse length. And I say ratio, but it's ratio expressed as a divide sum, or what we call a quotient. So the cos of this angle, say this angle was 45 degrees, we would put cos of 45, press equals, and that would give us a number, and that number would be equal to how long the adjacent side is compared to how long the hypotenuse is. And if we know either one or the other, we can find the one that we don't know. And then for the tan function, or the tangent, it's the other two that we haven't done in relation to each other yet. Tan function, the tan of an angle is equal to how big the opposite length is compared to how long the adjacent length is. So the tan of an angle is equal to the opposite side divided by the adjacent side. And when we talk about sides, we're always on about how long they are. Just a sort of daft way of remembering the sine function. It's like a fishing line, if you like. This is the hypotenuse, and this is the opposite side. So how much fishing line there is compared to how long the rod is. If you imagine this guy lifting the rod up, as the angle increases, the amount of line from the top of the rod to the water will increase. So the sine of the angle is equal to the opposite length, or the length of the line, divided by the length of the rod. And of course, we know this is the opposite side. As long as we define what this angle is, we're fine. A simple way of thinking about cos, they've both got C on them. It's a croc's mouth. That's the adjacent, that's the hypotenuse. But a better way is to say, get a daft example like this. Imagine you've got light coming down from a long way away. Imagine there's a sunshade, and this is the shadow that's cast by the sunshade. And what we could say is the cos of this angle is equal to the adjacent length divided by the hypotenuse length. And here, the length adjacent to the angle is the shadow, and the hypotenuse, the longest side, is the sunshade. That's just one way of remembering. And for tan, it's a bit harder to come up with something to remember it by, but you could say it's always right, because it's like a right angle. It's like a set square for those engineers out there. It's like a bookend. So the tan of this angle, when we have to know what this angle is, The tan of it will just be a number, probably expressed as a decimal, say, and that number will be equal to how big this opposite length is compared to how big the adjacent side length is.